Welcome back, everybody. Today I want to talk about some of the unexpected impacts of the AI boom and specifically how it's impacting enterprise IT. What does this modern day gold rush of AI adoption mean for cloud practitioners and IT teams? Some of the impact is pretty obvious. All of a sudden, your business, whatever your business might happen to be, has been thrust into an arms race where if you don't have AI, some kind of AI feature in all of your products, all of your workflows, you're behind the ball or perceived to be behind the ball against your competitors, and you haven't stayed relevant with the changing times. Um, the impacts of that are multifold within your organization. All of your deployment and product timelines have been upset like an apple cart. All kinds of things are happening within your business. And also, a bunch of new AI productivity tools that you hadn't budgeted have popped up into your OPEX budget out of nowhere. And you have to figure out a, how to pay for them, and B, how to use them. So these are kind of the obvious impacts of the current AI gold rush in the enterprise. There's some less obvious ones, though, that are really impacting the way that IT practitioners are able to do business. Some of the less obvious impacts I'm going to go over are something that I call GPU gravity, something CODB, or cost of doing business, the impact of cost of doing business of the AI boom, and then also more with less, or does AI make less more, or does it make more or less? We'll get into that a little bit. Now, when I talk about GPU gravity, what I mean by this is the closer the infrastructure is to GPUs, the more expensive and harder to find it's going to be. And what that means is multifold. GPUs, very expensive, very hard to find, very tight supply chain. We've known that for a while. The big neo clouds, all your big enterprise, the hyperscalers, everybody's gobbling up GPUs as fast as they can get them. NVIDIA and all the other GPU manufacturers are short. It's a known story. You know, if you want to put something on GPUs, you know they're in short supply, you know they're expensive. But so that's kind of the black hole that everything else emanates from. But once you get past the GPU centric servers are also short in supply, expensive, hard to get a hold of. That makes sense. Then you get to RAM, particularly large DDR5 DIMMs. GPU systems use a lot of memory. All the side systems that run a GPU implementation use a lot of memory. You've got container farms, you've got vector databases, you've got all sorts of things. So RAM, yeah, that makes sense. And then once you get past RAM, you've got NVMe, you need high performance storage to feed all these GPUs, okay? Then power, there's a ton of power that and cooling that's required by these systems. So that's getting harder and harder to find. The kind of high volume power distribution units, fluid cooling, and then, you know, you need a ton of east-west networking to be able to spread these GPUs across all these different systems. So now 400 gig high throughput networking, all of its corresponding optics, cabling, all that's hard to find. Then you get down to SSD. Well, if all the NVMe is sucked up and you still need more high performance storage, then SSDs are going to get more expensive. Then getting down further and further away from the GPUs, general pop servers are even getting harder to find because you need some kind of worker workload processing. Even the smaller 100 gig networking, the cost of NVMe RAM driving up NVMe, driving up SSD has made spinning hard drives, which are still required for large scale data lakes, pretty difficult to find and more expensive. So as you emanate away from the GPUs, any infrastructure that's anywhere in the rotation is going to be more expensive. But the closer you get to the GPUs, the more expensive it is, to the point where the RAM is up 5x, 6x from where it was a year or two ago. SSDs are 2 to 3x. Some of the networking is 2x. And this really makes a difference when you're talking about the cost of deploying um, infrastructure for AI ML on GPUs. Um, Big DIMS is big money, which is big problems. And memory DIMMs, disks, switches, storage, servers, it's kind of the same song in a different verse. And it doesn't just mean that your GPU-based AI ML workloads are more expensive. It also means all of your servers. So if you spec a data center refresh or an infrastructure refresh or any kind of infrastructure project a year or two ago, your budget that you had originally laid down is not going to buy you nearly what it did whenever you set it in. You may be getting half to a third as much infrastructure as you had originally planned, just because of the cost going up because of this run on enterprise infrastructure due to the GPU based AI/ML. This is causing some people to either accelerate or initiate migrations to the private cloud, because currently the hyperscalers have not multiplied their cost of these things of memory and CPU and performance storage to the same level that the hardware vendors are, but they will. So the trick there is, if you start taking these workloads and moving them into the public cloud, into the hyperscalers, into your AWS's, Azure's, Google Cloud and Oracle Cloud and the like, what's going to happen is you're going to get these workloads trapped onto their clusters, and then these markups will hit them as well. They just happen to have more of a buffer and more capacity than your average Joe does, but they are not nonprofits. They will be passing these additional costs on to you. And the cost of the hyperscale public clouds is expected to get significantly higher in the next 12 to 24 months. So moving out of the data center is not really an option uh, if if you want your OpEx run rate to remain anywhere reasonable. Um, so that kind of comes back to the cost of doing business, which was my second pillar. Just because AI makes things cost more doesn't mean your budget's going to get bigger. It's not only making AI infrastructure more expensive, kind of as I touched on earlier, it's making all infrastructure more expensive. So your commodity servers, which may have cost you $20,000 or $30,000 a year ago or a year and a half ago, might be $120,000 or $130,000 now. Those are real world numbers that we're seeing. And you can imagine how your budget, if you budgeted 10 servers or 20 servers, how a 3x to 5x increase in the cost of those servers is really going to be a problem. You're not just going to get more budget, more capital for acquiring hardware just because the market says that it costs more to buy. And this is a real challenge right now. And just the same time while you're trying to find budget to pay for these AI software expenses, so you've got the Claudes and the cursors and the all the things that all of a sudden wasn't a line item on your budget a year ago. You have to figure out how to pay for all that software. Also, all your cost of doing business, your standard enterprise operation hardware, software, networking, all of those things have become drastically more expensive. So at the same time that you really needed your hardware budget to get smaller, because you needed to find a way in your budget to make space for all this AI software that somebody bought because you need it, apparently, that you didn't know was coming, is the same time when all the hardware got more expensive because all this AI software has to run somewhere. There's a big hole in the market, so it's driving up the cost of all this RAM memory and all the components. Um, due to that GPU gravity that I discussed earlier, it just means more and more and more challenges with getting the right gear, uh, getting it in your budget, and figuring out how to run your business. Uh, the real world impact of this is just because there's a boom where AI needs a bunch of hardware doesn't mean that the enterprise stops doing what they're doing to let the neo clouds and the hyperscale AI clouds and all these AI workloads take all the hardware, and and we just stop doing what we're doing. There's real infrastructure that has to run banks, hospitals, stores, websites, manufacturing. Um, all the things still have to run. The world still has to function, even though there's this explosion of AI. There's still business that needs to be done outside of the AI space. Um, and even if you do have the budget, and even if you can justify buying a lot of this enterprise hardware, a lot of times it's back ordered and just not available because if you're a massive AI driven neo cloud, you're going to buy at a scale that if you're buying things 100,000 or 200,000 units at a time, you're going to get the pick of the litter. And the neo clouds are even getting pick of the litter over your traditional hyperscalers who already usually make a run on the supply chain of a lot of this infrastructure. So then you've got neo clouds sucking up gear, hyperscalers sucking up what's left, and then you've got very large enterprise and mission critical that's getting everything that's after that. And then if you're just a regular enterprise IT shop, there's not a lot left for you. You your cost of doing business and your ability to find the infrastructure that runs your business it's difficult right now. Um, what does this mean? How are businesses handling this and pivoting? I'm going to go into this a little bit more in another follow-up video, but what a lot of businesses that I've seen, they've paused hardware refreshes, changed virtualization migration strategies, moved workloads to the cloud, um, uh, extended the legs on existing infrastructure, older infrastructure that they would normally have life cycled out and decommissioned, purchasing lower spec, maybe workstation class equipment and using that for workloads as opposed to more consolidated, larger iron infrastructure. These are all strategies that we're seeing in the enterprise to be able to combat this GPU gravity and the larger infrastructure just getting pulled into this arms race of AI. But it can't get any worse than the hardware, right? And the software, the out-of-band software costs, the accelerated hardware cost. There's another third leg of this stool that's making things more difficult too, in the fact that you have all this unplanned AI software expense that's coming out of nowhere. That OpEx has to come from somewhere, and the way that the FANG and the large companies are doing this is they're laying off personnel to free up operational expenses or conversion to capital to be able to pay for the AI software and hardware. So at the exact time where you need more people to be able to do more with less with the scraping together the hardware you can get, and you need to train these people on this new AI software to where they can actually get the kind of efficiencies that we're hoping to get out of AI software. That's the same time when um, employees are getting let go. So how do you um, make room in your budget for these unexpected hardware, software, and SaaS purchases without letting go of your headcount? And if you do have reduced headcount, how are you able to do more with less by with the current employees you've got? How do you get those people to be able to adopt these new enterprise tools and get the kind of efficiencies that will allow you to cover the efficiency of the employees that are lost and make up some of the ground against your operating budgets. It's a it's an interesting problem and not an easy one. Um, so how do you survive all this? How do you make this work? I Great question. Hopefully I'll have some answers before I record the second part of this video. Uh, Thanks everybody.